In this video, we will go on to look at Chapter 5, Section 3, Solving Systems of Linear Equations by the Process of Elimination. There are really three levels to using the elimination process, and the first one, the easiest one, is when all you have to do is add the two equations together and one of the variables will be eliminated, as in x and negative x. When we add down each column, we're going to get 2y is equal to, that's 3y, is equal to 18, so y is equal to 6. From there, we are going to use the y in the first equation, so y x plus 2 times 6 is equal to 13. X plus 12 is equal to 13. Subtracting 12 on each side gives me x is equal to 1. So it appears the solution here is 1 comma 6. Now we need to test that in the second equation. Negative x, that would be negative 1, plus 6. Does that equal 5? And it does, so that checks. In the second equation, or the second problem, we have a similar situation where all we have to do is add down, and this time the y variable will be eliminated. So 9x minus 4x is 5x and equal to negative 15. And dividing both sides by 5, we're going to get x is equal to negative 3. We then take that x is negative 3, plug it into the first equation. 9 times negative 3 plus y is equal to 2. Negative 27 plus y is 2. Adding 27 on both sides gives us y is equal to 29. Now we need to check that, so we're going to plug both. So our solution appears to be x is negative 3, y is 29. We're going to plug those values into the second equation. Negative 4 times negative 3 minus y, or 29, and we want to see if that is equal to negative 17. So negative 4 times negative 3 is positive 12 minus 29, and that does indeed equal negative 17, and so that checks. And we'll scroll down. Now, another type of these problems, we can't simply add the equations together and have one of the variables be eliminated. In the second level of problem, we have to multiply one of our equations by a number. In this case, we can multiply the top equation either by a negative 2 or a negative 7 in order to get one of the variables to be eliminated. I'll always choose the smaller number. So negative 2 multiplying the top equation gives me negative 2x minus 2y is equal to negative 4. Then I copy the second equation underneath. 2x plus 7y is equal to 9. When I add together now, I get 5y is equal to 5, or y is equal to 1. We take the y value, plug it into the top equation. X plus 1 is equal to 2. Subtracting 1 from each side, we get x is equal to 1. Thus, the solution appears to be 1, comma 1. We still want to check that. We're going to go to the second equation, plug in 2 times 1 plus 7 times 1. That's 2 plus 7, which does indeed equal 9, and so that checks out. Number 12. For number 12, we are going to need to multiply the bottom equation by negative 2 this time. When we do that, I'll rewrite the top equation. 8x minus 5y is equal to 11. Bottom equation, negative 8x plus 6y is equal to negative 10. Adding down, I get y is equal to 1. That easy. I take y is equal to 1, plug it into the top equation. 8x minus 5 times 1 is equal to 11. 8x minus 5 is 11. Adding 5, I get 8x is 16. Dividing by 8, x is equal to 2. Thus my solution appears to be x is 2, y is 1. Now we're going to take those values, plug them into the second equation. 4 times 2 minus 3 times 1, and see if that indeed equals 5. 8 minus 3 equals 5, and that checks. All right, we'll go on to look at some word problems. In the first word problem, a service center charges a fee of X dollars for an oil change plus Y dollars per quart of oil used. A sample of its sales record is shown. Write a system of linear equations that represents this solution. Find the fee and cost per quart of oil. So we're looking for two things. X is the fee. Y is the cost per quart of oil. Now we have two equations. We know that each customer is first going to be charged a fee. That's X dollars. Then they're going to be charged for every quart of oil that they use. So 5 times y, x plus 5 times y for the first customer is going to be $22.45. X plus 7y for the second customer is going to be $25.45. So in this case, we can't simply add the equations together, but we can multiply the bottom or top equation by -1. So let's go ahead and do that. Actually, I'm going to use the top equation since those numbers are smaller, and when we subtract or when we add the positives and negatives, we'll get a positive value back. But it would have worked the same either way. All right, so I'm first going to write down the second equation because I know that's going to be the larger numbers. Then I'm going to multiply everything in the first equation by -1, and we're going to get 2y is equal to $3, which means y is equal to $1.50. So that means the cost of per quart of oil is $1.50. Now, we're going to use that value, substitute it into the first equation. When we do, we get x plus 5 times $1.50 is equal to $22.45. 5 times $1.50 is $7.50. So x plus $7.50 is $22.45. Subtracting $7.50 on both sides gives us x is equal to $14.95. So that would be the fee, $14.95. And the cost per quart of oil would be $1.50. Now we should still check that, so we're going to use the second equation. $14.95 plus 7 times $1.50, and we want to see if that equals $25.45. So we have $14.95 and 7 times $1.50 is $10.50, which does indeed equal $25.45 when added together. So that checks out. We'll go on to the final word problem in this section. Okay, so a music website charges X dollars for individual songs and Y dollars for entire albums. Person A pays $25.92. So what are we trying to figure out here? X equals price of individual song. Y is equal to price of album. And that's what we're trying to figure out. So the first person buys 6 songs, 6 times X, and 2 albums, 2 times Y, and he pays $25.92. The second person buys 4 songs and 3 albums and pays $33.93. Now, again, we can't simply add here, and we can't even just multiply one of the equations by something. We have to multiply both equations to get a least common multiple. And I will always choose a smaller number, so we're going to work with the y's and make them both 6y, one of them positive, one of them negative. So we will work with the first. We'll have the first equation multiplied by 3, the second equation by negative 2. When I multiply, first equation, I get 18x plus 6y is equal to $77.76. Second equation, I have negative 8x minus 6y is equal to negative 2 times 33.93, and that gives me negative $67.86. At this point, when I add down, I should get 10x is equal to $9.90 divided by 10. I end up with x is equal to 99 cents. So we're going to take that 99 cents, we're going to x equal 99 cents, we're going to plug it into the first equation. So 6 times 99 cents plus 2y is equal to 25.92. And 6 times 99 cents is $5.94 plus 2y is 25.92. Subtracting 5.94 on both sides is going to give me 2y is 19.98. Dividing both sides by 2 tells me that y is equal to $9.99. So that means it appears that the price of one song is 99 cents, the price of one album, $9.99. Now we're going to check this by plugging both numbers into the second equation. 4 times 99 cents plus 3 times $9.99, and we want to see if that equals 33.93. So we have 4 times 99 cents is $3.96, and 3 times $9.99 is $29.97. And again, does that equal 33.93? Well, when we add 396 plus 29.97, we do indeed get 33.93. And so the two sides are equal, and that means our values are good. All right, so that's going to do it for this section.